The objective of this lesson is to use the partial products algorithm to multiply one digit by up to 4 digits. In previous lessons, students used area models to multiply multi-digit problems. Students should be able to multiply using the partial product algorithm without drawing the area models. But some students may need to use the model until they are confident in the transition to the partial product algorithm. The partial product algorithm breaks apart factors larger than 10 according to their place value. This allows students to break apart the multiplication problem and solve easier pieces, and reinforces why 40 times 6 is not just 24, but rather 24 tens, which is 240. Let's look at the multiplication problem of 6 times 43, and let's use an area model along with the partial product algorithm to solve. In this multiplication problem, we have one factor greater than 10, so using the partial product algorithm is an effective way to solve the problem. But let's start by drawing an area model first. Start by drawing a long rectangle and label the rows 6 and the columns 43. Next, let's decompose or break apart the factor 43 into 40 and 3. We are separating the tens and ones. Draw a line in the rectangle to separate the tens and ones. Now calculate by multiplying 6 times 40 equals 240 and 6 times 3 equals 18 and adding the partial products for a total of 258. In partial product multiplication, it does not matter whether the smallest place value is multiplied first or the largest. The product will be the same. We can multiply 6 times 40 first to get a product of 240. Then we can multiply 6 times 3 to get a product of 18. The sum of the two products is still 258. Let's try another example from the following problem. This time we will be multiplying a triple-digit factor by a single-digit factor using the partial product algorithm. The Macaw Zoo needs about 268 pounds of food each day to feed all the animals. How many pounds of food do they need each week? Let's start by writing the equation 7 times 268 on vertical lined paper. A simple way to create these vertical lines is to turn a lined piece of paper vertically. This will aid in the alignment of the digits. Each column represents a different place value. Let's make sure each digit is in the appropriate column. We have the ones, tens, and hundreds. Start by multiplying 7 times 8 for a product of 56. As we solve the equation, we will write the multiplication equation out to the side. Next, we will solve 7 times 60. Keep in mind that the digit 6 is in the tens place, so its value is not 6, but 60 or 6 tens. 7 times 60 is 420. Next, we will multiply 7 times 200 for 1,400. Again, writing our equation out to the side. Now we can get the sum of all the partial products for our answer. So we will add 56 plus 420 plus 1,400 for a total of 1,876. When adding the partial product using the lines, it keeps the digits lined up in their correct place value spots. While using area models and drawing arrays are an effective way at solving multiplication problems, it is more efficient to use the partial product algorithm when solving multi-digit multiplication equations. The objective of this lesson was to use the partial products algorithm to multiply one digit by up to 4-digit numbers. We met this objective by using the partial product algorithm to solve multi-digit multiplication problems.